Hi, I'm Tom Hollingsworth. Welcome to Networking Field Day. We're here in Mountain View, California at the offices of VeloCloud. The presentation that you are about to watch features VeloCloud's products and solutions and a group of networking community delegates who are invited to ask questions, make comments, and offer their opinions in front of a recorded video. If you would like to learn more about this and other exciting topics, including how to become a delegate or a presenter at the event, please go to our website at techfieldday.com. If you'd like to watch more videos about this and other exciting technology topics, please see our YouTube channel at youtube.com/techfieldday.
So in this next section, let me cover the overview of our SD-WAN solution. So let me just start with a recap of what SD-WAN is. So it is a logical layer 3 overlay network. Right? Basically, the goal is to encompass any transport, whether it's private, public, wired, LTE. And basically the way we do that is between any two SD-WAN nodes. So it's a dual-ended solution. If the node is on-premise at a branch, we call it an edge, or we put larger edges as hubs in data centers. These edges can be appliances or also virtual software that will run on any x86 platform, and we'll talk about the variations a bit later. We can also deliver the same termination point in the cloud. Right, so this is, in that case, it is virtual, but it is a multi-tenant solution, so that can be deployed directly to get the exact same benefits to a cloud destination. Right, so and the goal of this overlay between any of these two SD-WAN termination points is really key 3 items, which are also, we feel, our key differentiators. One is to simplify every aspect of WAN management, especially as enterprises want to use multiple links and multiple transport to make that very simple, but really simplify everything from deployment to the use of multiple links to service insertion to ongoing operations. The second key thing is to really a big focus on assuring application performance. Right, so not only do we want to use multiple links, right, but we really want to make sure the apps work no matter what link we use, and we'll cover this later, even if we use only a broadband link. So really to give you the flexibility of using any link, but achieving the goal of assuring app performance, even for your most demanding applications. And then the third goal of this overlay is not just to do that between enterprise sites, but as was clear in Sanjay's presentation, the workloads are moving to the cloud. Right? In fact, at the recent trade show we were at in New York City, one of the biggest financial institutions came to us and said they now have a mandate that no new workloads are going to be deployed on premise. Last year, we saw a lot of these companies say we're pushing a lot of stuff to the cloud. This year, they're actually saying everything new is going to be deployed in the cloud, which is why it's absolutely key that any benefit that we have can also be extended as an on-ramp to the cloud. So on this slide, general architecture, one of the things I'm going to cover, because we have to forgive us later. We all talking too many acronyms. So I've actually added this is the translator key code for the rest of the presentations today. So again, this architecture, you see that we have in the branch our VeloCloud Edge, or VCE, so VeloCloud Edge. So for on-premise traffic, right, we can take advantage of public broadband links. We can take advantage of private circuits with another edge that's in the data center. If we're going to the cloud, right, we have the the hub here includes the private. If we're going to the cloud, we have distributed cloud gateways that are actually delivered by VeloCloud as a hosted service, and we'll cover that infrastructure in a little bit. So they will take you direct to your SaaS application, to your infrastructure as a service, but with all the same performance, availability, security, and manageability. The additional benefit of the cloud gateway is actually you can also do a hubless design to even access an on-premise data center. Right? You just do the SD-WAN termination from the edge to the gateway that's nearest to the data center and have an interoperable VPN tunnel to that data center to existing equipment. So we can get to on-premise applications with the hub installation, we can get directly to cloud applications, and we can also get to legacy sites using the cloud. But for on-site traffic, does not have to go through the cloud. But you always have the option, if you're sending traffic to the cloud, why not use a cloud resource to terminate that traffic? So that's the advantage. So we have site-to-site SD-WAN, plus all the benefits of having cloud SD-WAN as a service. So one of the things that, as over the past 2 years, we've won, and you saw on the previous slide, some very large enterprise accounts. So even though we are called a cloud-delivered SD-WAN solution, I want to be very clear, we have, for some of these large customers, done a fully on-premise SD-WAN deployment. Right, so you see in this picture, it's the branches to the data centers, and then even for breakouts to the cloud, we can actually support regional breakouts and forward traffic from a branch to a regional hub before it goes to the internet. The orchestrator is moved on premise. One of the challenges of that is then how do you take a cloud scale infrastructure and move it on premise? So we have two nice things. We have a great way to move a VCO and still have redundancy, high availability, disaster recovery, packaged simply for enterprise. And the other thing is to move the gateways. There's no gateways, all the hubs on premise in a data center, and we have a clustering capability that can scale to the largest data centers and the largest number of sites for the customer. So bottom line, despite the name, we can also do a fully on-premise deployment. But as you saw on the previous slide, if you have traffic going to the cloud, there really is an advantage to use a cloud gateway for cloud-destined traffic. As Sanjay mentioned, we have a couple of very significant service provider deployments. So the other aspect of cloud is not that it just gives you access to SaaS applications and infrastructure as a service. It provides SD-WAN access to a service provider network. Right, so if you have the private network of service providers, the way it provides the access is now the gateways are deployed on-premise in the provider's network. So two different cases. If you have a provider hosting applications, services in a data center, you can put the gateways directly into that data center. So a good example is we have a bunch of providers providing unified communications as a service. So the branch edges connect directly to gateways co-resident with their hosted applications. The other one for the large tier 1 carriers, the gateways are deployed at their network POPs. So we can then do SD-WAN for simple branch deployments. SD-WAN can provide the flexible transit. So it could be a hybrid network, peer broadband, dual broadband, but we still have the benefit if the customer has a private network, that last mile traffic can still hop on to the private core. So in fact, while this is shown as a provider solution, this is really key for the largest enterprises, because all the large enterprises want the flexibility on the last mile, but they will typically have an existing backbone, existing data centers, existing sites on that backbone, and they want to leverage that in the mix. The fact that we uniquely have these cloud gateways can provide the interoperability between the SD-WAN and access to the existing private core. So in fact, they can access the data centers without installing a hub in this data center. So sort of a hubless design for existing sites. So the providers have come out, they call it a VeloCloud powered managed SD-WAN solution. The key to that is we have multi-tenant solution. And typically when we hear about that in the cloud, it's management. The key is it's the data plane. So not just the management, but the actual data plane in terms of the gateway are multi-tenant, designed to be deployed in the cloud. Additionally, on the orchestrator, we have, from the very start, a multi-tier orchestration system. So not just designed for the end enterprise, which will get a self-service portal. You also get a channel portal, and the provider gets an operator portal where they actually manage not just the customer's sites, but actually the deployed gateway infrastructure in their core network. So the one other thing I'll cover is I know when last time we launched the SD-WAN solution, it is based on SDN principles, but we did adjust that for the WAN environment. So I call this a hybrid SD-WAN approach. So we kept the distributed control plane. Right, so it's important for internet WAN scalability, redundancy, no latency in terms of the forwarding plane, no single point of failure. There is local control. So each node knows forwarding decisions. And also when we talked about the multi-link and the link metrics, each node also does its own monitoring of the links and knows the link conditions for using the multiple links. However, we do have centralized control policy. So the issue of trying to manage all the data and policies from individual nodes and have to look at routing tables individually, we do have the centralized policy and the orchestration. So basically captured the best of both worlds. So I know in the first NFD there was concern to say, oh, if it's an SDN model and the remote branch loses connectivity to the control and orchestrator, does the forwarding plane stop? Nothing stops. All the forwarding plane decisions are made locally, but the policy is centralized for easy enterprise-wide visibility as well as easy programmability. Okay. Yes?
Do you plan to go into the details of how you distribute that policy and how you pass the link condition information?
So this advantage of the centralized orchestration applies to a lot of things. We will do a deep dive on how that applies to the routing, which is what we call the overlay flow control. Yep, and we'll do a demo of that as well. So as I mentioned, there's 3 key benefits. So I'll just quickly highlight the 3 areas. So one is simplified WAN management. That really cuts across a lot of functionality throughout today's presentation. I'll hit some of the key items, and some of the other simplification we'll touch later. So first, obvious benefit is centralized SD-WAN orchestration. And basically, it's all in one tool. So we are really building everything in there: configuration, monitoring, troubleshooting. Absolutely no CLI is required anywhere in the process. So really making everything available via the GUI or via our REST API, which is what you'll see in the Earthlink case study. They've done their own version of a managed SD-WAN service. It's also available as a hosted service, right? So except for those largest enterprises, you don't have to install the orchestrator appliances as well. As I mentioned before, we have the operator level on the very left, where the operator can see their multiple tenants. An enterprise would get their self-service portal. They can see an enterprise-wide view of their entire SD-WAN, the different branches, the different links as well. And then very easy drill down. So one-click drill down to an individual branch. At an individual branch level, they can quickly see all the individual links with all the performance parameters of the links. And I'll cover that, how we use that in our optimization, as well as a lot of useful information in terms of link usage, traffic, source destination application usage as well. A second area that we really spend a lot of time to simplify is really the branch deployment. Right? And there's two modes of this. So on the left-hand side, we call it zero-touch activation. And it's really zero IT touch. So the key is, for both these methods, I don't want to have to send an IT person out onto the remote site. I don't want to have to take the box, open it, pre-stage it, configure it before I send it out. Obviously, if you pre-stage it, then you also have a risk of you put the configuration in the box, and there's a security risk if it's lost. The box is absolutely not configured before it's sent out to the site. The flip side is you also don't need to do any site-by-site profile in terms of when we use the multiple links, the box will discover the individual links, the capacity, performance, and then apply a universal policy as opposed to programming, oh, this site has this capacity broadband, this capacity private link, and have to do a site-by-site configuration. So quickly on the left-hand side, the zero-touch means the remote installer actually activates the device. So quickly how that works is we just ship a plain vanilla box. It goes onto the site. In step number 2, the administrator creates a logical configuration for that site, emails the key to that installer. Step 3, the installer plugs in the power, the cables, puts that email key, but just browsing into that the Wi-Fi in the box. It pulls then down it knows this box now belongs to which enterprise, which profile within the enterprise, pulls down the configuration and becomes activated. The installer can be doing that at midnight. The central IT person can be on vacation and asleep. The box gets installed. Very simple process. No device tracking is needed. You don't need to know which box went to which site. It just requires that you email the key to the installer. Just to have ultimate flexibility, we have a second provisioning method that we're working on with the providers. It's basically for a remote push activation. In this case, a central NOC will activate the device. So all the same benefits, except they get an independent installer. So they ship the box, the installer powers on and connects the link. It connects home through a redirector to the cloud and says, I'm installed, I'm ready to be managed. And then it's up to the NOC to then push the desired config to the box. So ultimate flexibility.
So
yes,
realistically, for whatever branch office, like a retail store with many, many sites, after ISP connectivity is in there,
yeah.
how fast can the site be up? It sounds like a matter of minutes, really, after shipping.
Yeah, no, it's absolutely is a matter of minutes. We've had cases where the installers wanted to go get a cup of coffee and doesn't have time to do that. A nice one we had with one of our provider partners, they were using actually a retail store. They went to a third-party provider for the last mile private circuit. It did not show up. So the circuit was not provisioned. Half an hour before opening, they decided to try out our solution because we were just in POC with them. They dropped in our box. They dropped in 2 LTE links. They called home to our cloud-hosted orchestrator. And this is half an hour before the store had its grand opening. They got it up and running. Unheard of in the past.
For companies that require static IP configurations,
yes.
Is it recommended to deploy this with LTE so that way you can get it activated and get that static information configured?
So we have different options. We can probably discuss later. One of the actually nice things we have in the key is if you do the pre-configuration of the logical, you can put the static IP actually in the key, and the key will place it in the box to get the connectivity to get to the orchestrator. Another key simplification is, again, workloads are moving to the cloud. If you're using infrastructure as a service, VPN setup. So VPN setup from the branch to enterprise site, obviously, it's fairly easy today because you normally manage both ends. The challenge is, if I've moved the workloads to the cloud, people have come to us and we have an end-by-end problem because now I have one vendor's router in the branch, and then I have to connect to Amazon Azure. It becomes n branches by n cloud data centers, a manual 2-sided IPsec tunnel setup, depending on the IP address and changing every time there's a branch move out or change. This is where we have the benefit of our cloud gateway at the doorstep of all the infrastructure as a service data centers. So all the branch connectivity automatically connects to our cloud gateway. And then our cloud gateway has a one-time setup to get secure access to the virtual networks for that customer at Amazon, at Azure. So really simplifies the secure connectivity to multiple cloud data centers. It's a very, very nice use case. So the last area that I want to point out is the service insertion. So we also have one-click service insertion. We call it for hybrid services. So whether you want to install services on-premise or in the cloud, instead of doing complicated node-by-node routing, CLI, it's all GUI driven. It's actually application aware. So in this example, you can send different application traffic. So basically, if I have web email traffic and I want to do DLP protection on-premise, but I don't want to do it at every single branch, I can forward it to regional security centers. So we're seeing that a lot in larger enterprises where they want to not backhaul it all the way to a central data center, but not have to distribute a security service to every branch. I want to have regional security hubs, but how do you make it easy to get traffic to those? We can do that one click. Web traffic, if it's going out to the internet anyway, let's do the security scrubbing in the cloud. We have partnerships with the different cloud security vendors. Again, sending traffic policy-based to the cloud. Or in fact, if you have trusted sites, you can send it directly out without scrubbing, basically supporting a mix and match of security services or other services on-premise and in the cloud.
Steve, on this, there's no standard way to do service chaining like this. So how are you guys doing it?
So it's basically our tunnel setup from our SD-WAN node in the branch to a hub in a regional data center, or to our gateway in the cloud data center. So we have the and then the gateways, for example, with Zscaler, our gateways are connected to the Zscaler services.
But when you get to when you're on you tunnel to another VeloCloud device, and then from there to pump the traffic through the device that's doing the inspection. Am I physically having to plug that device into your gateway to get the handoff, or do you do a packet rewrite?
No, so we use tunnels basically to connect to these cloud applications. So we have both proxy mechanisms as well as tunneling mechanisms to deliver it to their final cloud application. So that is the way we connect to ForcePoint and Zscaler today.
I couldn't hear most of that. I'm sorry, but
Sorry, let me repeat that one more time. So we have two mechanisms in order to service chain to cloud providers. So we can do proxy efforts where we rewrite the headers basically into an application. And then the other mechanism is to do tunnel delivery, so that we build an IPsec tunnel, standard-based IPsec tunnel into these providers, and then hand the traffic, select traffic to those providers. And that is something that you can still influence through the business policies. So it's not that you have to send all of the traffic. You can very fine-grained carve out specific traffic that you want to send to those providers.
But the key here is, instead of building tunnels from every single branch of a site to Zscaler, you'll have to build IPsec tunnels. So let's say if there are 100 Zscalers, 100 branch offices, one Zscaler site, you'll have to build 100 IPsec tunnels. Now the traffic is going to the cloud anyways, so all these branch sites can connect to our cloud gateway automatically, and from the cloud gateway we can build a single tunnel to Zscaler. Right, so that way we are eliminating the number of tunnels required and the number of amount of configuration needed. The other thing is the service can be inserted, and we'll cover this in one of our sessions. Service can be inserted in the branch, in the cloud, or on-premise. So even in the branch, we'll do a demonstration today where we are seeing a virtual service inserted in the branch office. And this is our own mechanism that we have built. It's the secret sauce. Again, we'll demonstrate that today.
Yep. Thanks, Parag. So those are some examples of simplification. The other one is the overlay flow control, which we'll do in the next section. I want to cover the second benefit quickly, which is the assured application performance, and talk about our dynamic multipath optimization. So this is a key benefit of our solution. So the three key components are automatic and continuous link monitoring. So this is both for capacity and performance. So actually that does also drive the simplicity, because that's what removes the manual site-by-site configuration to the link, because we discover it and use that for the policy configuration. But the continuous link monitoring and discovery as you plug in the links of the capacity performance then drives our optimization. There are two key components of the optimization. One is dynamic per packet steering. So based on the link measurements, knowledge of the application, and the IT manager will put in his application priority. We do have a set of defaults. We will determine which link to best steer the different applications on. And this is also aware of the network requirements of an individual application. Because we do per packet, mid-flow we can move a session, for example, a voice call. If we start on one link but it has degradation mid-flow, sub-second, without dropping the call or the user hearing any impact, we can move it to a different link. The other benefit of the per packet is we can take a high bandwidth file transfer and split it across multiple links. Again, we have termination at both ends, so then we can reassemble the flow on the other end, make sure the sequencing is correct. So this is a key function of the solution. And then in addition to that, as important, right, if you only have one link available, or you have concurrent problems on both links that you can't steer around, then we also have on-demand remediation. So we only do that if required, only for the priority applications. So for example, for voice calls, we'll do forward error correction. We'll do jitter buffering. For TCP transactions, we'll do fast negative acknowledgement and have our SD-WAN nodes, if we detect that we're missing a packet, retransmit, shielding the application from seeing the packet loss so they don't, so we still maximize the window sizing. So that enables single link performance. Good example on the left, actual GUI screenshot. That was a nice use case as well. So this was a retail customer. They initially had MPLS as a single link for their branches. But the MPLS actually did have still some degradation in terms of packet loss. We deployed SD-WAN with a second link that was broadband, commodity broadband. In fact, during this POC, you can see the MPLS link actually went down for a period of time. We switched the traffic over, voice traffic, to the commodity broadband, which you see why people were hesitant to use broadband for voice or critical traffic, because it had packet loss and jitter problems. We did the on-demand remediation, and the top bar shows the effective application performance, which was a solid green, perfect voice performance, even though there was an issue on actually both of the links that were connected to the site. So that is the key part of our solution, assuring app performance over any combination of links. And in fact, the next use case is the, we often get asked, does this work on a single link? This is actually named a case study, Meineke Auto Shops, where they again had a single broadband link. They encountered a lot of performance problems. But through the remediation, right, we couldn't steer around it. There was only one link. Through the remediation of the error correction and jitter buffering, we were able to give them great performance. And they said, you know, we don't even need a second link to do this. So this has been deployed for quite a while. Over the past years, we've been collecting a lot of data on how this works. We published something called the Internet Quality Report. This is a quick summary, but basically the end result was, if you were trying to use just broadband internet to carry quality voice, 18% of the time, and this is calibrated with the traditional MOS scores, 80% of the time your voice calls would not be good. But using the SD-WAN overlay with two links, two broadband links, so we can do both the combination of steering and remediation, the end result over all this data collected was that you can get high quality voice calls over broadband 99% of the time. It was, I think, 99.5% of the time. So in fact, we have some voice providers who previously gave voice SLAs only if you deployed a private link. If the customer deploys two diverse bring your own broadband, they now are willing to give the same SLA that they used to give for a private circuit over a broadband WAN. That's how well this has worked over the past 2 years.
So you're duplicating the packets you send from one of the sites to the hub, right? Over
Correct.
both links.
So from one end to the other end.
And then you choose which one.
If it's a high priority application, if there is link degradation, and if the application requires it. So if you say, if you mark a backup storage application high priority, we don't care if you lose packets, but if it's a high priority voice application and there's link issues, then we will pull out all the stops in terms of trying to steer around or remediate the problems.
Are both the edge and the gateway making that decision of which one of those packets gets forwarded to the destination? Which one's the better packet?
So both sides have the forwarding information as well as the link condition information. So we can actually make, one of the key things is we actually measure and can make unidirectional decisions as well. So the upstream may go on one link and the downstream for the same flow could go on a different link. So that's the level of granularity we have.